Take a piece of rubber that's been cured, and you can do about anything you want to try to destroy it, and it comes back to its original shape. It's just got such tremendous engineering properties.
The rubber industry needs all types of disciplines, from chemists and engineers to technicians and salespeople, and a whole lot more.
Some of the largest chemical companies in the world are involved in either making polymers or raw materials for the rubber industry. I mean, this is a huge business. So the chances of you moving up, you wanted to go, no matter what side of the business you want to go to, technical, marketing, sales, the business side, accounting, whatever. There's lots of opportunities to grow.
Rubber is a very important engineering material, which is essential to advancing and maintaining a modern-day technological society.
Very few people understand that their lives are surrounded by rubber technology, that there's rubber parts that are critical to all kinds of things we do every day, just in transportation and certainly in medicine.
Rubber isn't just the sap that comes out of a rubber tree, and that's all it is. Most rubbers that are used today are actually, or elastomers, are synthetic. They're made chemically, and there are always new additions, new grades, new blends, new, all kinds of things as a need arises. So there will be opportunities in the future to be that person that comes up with the next best version of an elastomer.
Rubber is not too difficult to understand the basics. It's extremely challenging to be an expert in it. The applications are amazing with rubber, and they go in all different areas. There's tremendous amounts of healthcare applications for elastomers these days. LEDs, optically clear elastomers that maintain optical clarity over a very long period of time, whether it's in a solar panel cover to these LED billboards out in the street. If you have a smartwatch with a band, it's an elastomer. If you have a coating or a cover on your iPad and iPhone, those are elastomers.
All the hoses, all the gaskets, all the seals on windows, the tires, and then even you get into the medical side. You go to the hospital and you get IVs, and there's stoppers in the syringes. All those things would be gone if it wasn't for rubber and all the things it can do.
The most promising markets, in my opinion, are those that are high technology oriented. Aerospace and oil and gas, things where the environments are harsh, the demands are high.
Cars are getting smaller, the engines need to have more robust parts in it.
Modern technology depends as much on elastomer technology as it does on steel or concrete or anything else. For us to make taller buildings and faster planes and go to space or whatever, rubber technology is going to have to remain a part of that and keep advancing.
The field's wide open. It's only bound by what binds you. So let yourself go. Think outside the box.
When asked what market has the most promising future, I would say the healthcare industry. The need for improved materials and products used in medical instruments, equipment, and packaging is increasing.
A great deal of R&D is going into fluoroelastomers, silicone rubber, functionalized solution elastomers, and new thermoplastic elastomers.
I was always interested in chemistry. That was in high school. I explained to an advisor once what I was interested in. I said, I like chemistry, I don't want to work in a lab, I want this. I made up a list. He said, oh, that's chemical engineering. I said, oh, really? I said, I never heard of that before. Back then, 40 years ago, or 45 years ago almost. And I said, okay, that's what I want to do. I was amazed that at 17 years old, I picked a field that I enjoy now, many years later.
It's important starting out to join a large, highly professional rubber company from which you can learn a great deal of applied rubber technology.
I think there's still a lot of room for career growth in the rubber or elastomer industry. For one thing, universities have pretty much quit teaching rubber. So anyone who gets into the industry and develops rubber expertise will have value, especially in the areas that are high-tech. And by that, I mean seals and O-rings, mounts, vibration isolation devices, tires. Those are not being replaced by thermoplastic elastomers and plastics. There's still no substitute for rubber.
What you want to do is get as broadly experienced as you can. So it's possible to be a rubber technologist and spend all your time in the laboratory. And I said, no, you really want to get out into the factory and get out there and understand what people are really doing, make relationships with factory people and production people so that you understand them and they understand you, because when you get the benefit of their point of view and their work and what it's like, it'll make you a stronger contributor yourself in developing the skills that you need to do the job better and better.
We have customers in the synthetic rubber business in 24 or 25 countries at this point. So we get to see different cultures, different people, different ways of doing things.
The best thing I can say about the rubber industry, it's truly a community. So once you're in and the connections you make and the people you know, it is a family and a community, and you can make a good living and have a good career and meet wonderful people.
The first valuable lesson is opportunity does not offer a second chance. Be ready. By this I mean get all the experience you can, get the college degrees, take additional professional training, and volunteer for projects that may come up outside your primary position description.
I have a bachelor's degree in physics. I have become a rubber chemist through on-the-job training. I have 17 patents already. No one in the patent office asks, does he have a PhD? Once you have rubber technology training, you can go anywhere in the rubber industry.
It's something different. You have to use your mind. I'm 75, and every day I learn something new.
Never give up. There's always an answer, and never say no.